told what tan is. So we're going to construct a right angled triangle to help us solve this. So if we construct our right angled triangle here for the unknown alpha, then we know that tan of our angle is the opposite divided by the adjacent, which tells me that the opposite side to the angle in this case must be a 2, and the adjacent is root 5. So we're going to label on here 2 and root 5. So then we can look at this and we've got a right angled triangle. So Pythagoras holds. So Pythagoras says that the two shorter sides squared add up to the longest side, in this case the hypotenuse here. So that adds up to the hypotenuse squared. So if we just work this through, root 5 squared is 5, 2 squared is 4, and that's equal to the hypotenuse squared. So therefore 9 is the hypotenuse squared, and therefore the hypotenuse is equal to 3. So we're going to replace the word hypotenuse here with a 3, which gives us what we need there. So then, just getting rid of what we've just done here, we're then going to use this triangle to firstly show that sine theta is 2/3. So sine alpha is 2/3. So sine alpha, we know, is opposite over hypotenuse. So the opposite side in this case is 2 and the hypotenuse is 3. So that's shown. And cos of alpha, which is the second part of this, which is the adjacent over the hypotenuse, that must be the adjacent side, which is root 5, divided by 3. Okay, for part B then, also for part 2, part 2 here, we're moving on to, we are asked to find the exact value of sine 2 alpha. So what I've got here is a snippet from the formula book, which is going to help us if we've forgotten what sine 2 alpha is. So in this case, our A and our B from our formula are both going to be equal to alpha. So sine alpha plus alpha is equal to sine alpha, let's just do that properly, sine alpha cos alpha and plus cos alpha sine alpha, which is the same as saying 2 sine alpha cos alpha. Now, we've already done in the previous part of this question what sine alpha and what cos alpha are. So just give myself a little bit more room here and substitute in what we know. So we've got 2 lots of sine alpha, well that's equal to 2/3, and cos alpha, that's equal to root 5 over 3. So we're multiplying those things together. So I'm going to get 4 root 5 as my numerator and 9 as my denominator there. And that is my exact value for my 2 marks in part B. Now, to finish this question off, part B, we need cos alpha and we're going to need cos beta. So we're going to have to create another right angled triangle here. So if I create another right angled triangle, but this time for the angle beta. So I've got my right angled triangle, my unknown beta. Scrolling up to the question, we're told that tan beta is a half. So if tan beta is a half, we'll work down here, then that means that we have opposite over adjacent is 1 and adjacent is 2. So then using Pythagoras again, 1 squared plus 2 squared is equal to the hypotenuse squared. So 1 squared plus 2 squared is 5. So the hypotenuse must be root 5. So we'll fill that in up there. So get rid of all of my workings here, which I don't really need, lucky for me. So now, looking at what we're doing, we are trying to find cos alpha minus beta. So using the second double angle formula now, cos of alpha minus beta. So that's going to be cos of alpha, cos of beta. Because it's minus, it's the other second one, which is a positive, sine of alpha. Sine should be sine of beta. So each of these things are exact values that we can now find. So cos of alpha we've already got from the previous part of the question is root 5/3. Now that's being times by cos of beta. Now cos of beta is going to be cos, which is adjacent over hypotenuse, so 2 over root 5. And we're adding to that sine of alpha, which we've got from the previous part, 2/3, and we're multiplying that by sine of beta. Now sine is 1 over root 5. So then if we just bring a bit more space again, let's tidy up our fractions. On this first one, the root 5s are going to cancel. So we're going to be left with 2/3 because the root 5 and the root 5 are cancelling out. And on this second one here, I've got 2/3 times 1 over root 5. So you're probably looking at this thinking, well, that does not equal what I've been asked to show that it can be expressed as. But what we need to do here is the process of rationalising this denominator at the bottom here. So what I need to do to rationalise the denominator is times top and bottom by root 5. So I'm going to leave the 2/3 alone for a moment and just times top and bottom here by root 5. So I've got 2 over 3 root 5, and I'm timesing top and bottom by root 5. So that's going to leave me with 5 times 3, which is 15 as my denominator, and 2 root 5 as my numerator. And that's now being added to 2/3. Now we can see here that now we don't have the same denominator, so we've got to make a common denominator by altering this second one. So this is going to be written as, and I'll just write it on the same line for ease of space, that's going to be the same as 10/15. So I've got 10/15 plus 2 over 5/15. Now the question says to take a factor of 2/15 out the front. So I've taken 2/15 out of this one, and I've taken 2/15 out of this one, which is going to leave me with the 5 here. It's 5 times 2/15 will give me 10/15. And in this case, I've taken the 2 out, so I've been left with root 5. So our value of k is in fact 5. And then that question is now complete.